Let's look at number 1 for Monday, January 14th. Assume the situations are proportional. That means they're going to form a proportion. Find the unit rate and then solve. A car can travel 476 miles on 14 gallons of gas. How many gallons of gas does the car need to travel 578 miles? Anybody have an answer for that? Asia? 17 gallons. How did you solve that? Okay, good. What I'm not seeing is you guys, some of you putting units for miles and gallons. Remember, that's really important on harder problems, that you make sure that you are putting a unit for miles and gallons. Because over here, our proportion, for these to be proportional, if miles is our numerator here, miles has to be our numerator here. If gallons is our denominator, this has to be our gallons. And so it says, how many gallons of gas, how many, we're trying to solve that, does the car need to travel 578 miles? And so the first step is to cross multiply this way. And you get 578 times 14. And that's 8,092. And so whatever the gallons is times 476 should be 8,092. Well, I don't know what I'm going to multiply by there. So what's the inverse or opposite of multiplying, Michaela? We're going to divide. So I already have 8,092 in my calculator. So now I just need to divide by 476. And you get 17 gallons. You need to make sure that you have a unit with that 17. And if you have all your math crammed into this little tiny spot, you need to have your answer circled before you come and have it checked with a teacher. I've seen a whole bunch of you this morning that I've sent you back and told you you need to circle your answer, or you need to have a dollar sign with it, or a word with it, or if it's money and it has change, you have to have 2 places past the decimal. You are in 7th grade. You are a year and a half away from high school. You know that change in our money system goes to 2 places, right? So you have 2 after the decimal. So you can either not have a decimal and no change, but if you have change, you have to have 2 places. All right, let's look at the next one. Mrs. Baker paid $2.50 for 5 pounds of bananas. How much would Mrs. Baker pay for 8 pounds of bananas? Someone tell me how you set this one up. Shay? $2.50 over 5 pounds equals, what do you have over on the other side, Shay? Okay, so, but did you know the $4? How did you set it up? You put the 8 pounds over here on the bottom, 8 pounds over here on the bottom, and then that actually looks like 81, doesn't it? Okay, 8 pounds, and then cross multiply. $2.50 times 8 pounds. And you get 20. And so when you cross multiply this, 5 times something should equal 20. And what is that something? 5 times what is 20? 4. So your answer is $4 for 8 pounds. Yes. Are you finding the unit rate and then multiplying? Okay, so it's kind of the same thing that we're doing. You just are setting them up different. Okay, another way you could do it is you could find the unit rate like the answer or like the directions told us. What's $2.50 divided by 5 pounds? It's 50 cents a pound. So you could find the unit rate here of 50 cents a pound, and then you could multiply times 8, and you get $4. So that's another way to do it, right? Okay. Make sure that if you left your answer like this, that you circled it, but that you put a dollar sign with it. Okay? All right. 3, find the selling price of a $270 bicycle with a 24% markup. What does that mean? Can somebody tell me what that problem means? What's a markup? Krill? Yeah, right? So a store buys things for a certain price, and then they have to mark it up and then charge a customer a higher price. That's where they get their profit from. Can someone tell me how they solved number 3? There are lots of different ways to solve number 3. Can somebody tell me how? Krill, how did you solve it? For the markup, okay, and then what did you do? And you got $334.80. That's one way to solve that problem. Very good. Anybody solve it a different way? Anybody use the proportion, the percent proportion? You could have done 270, 24 over 100. Anybody do that one? You got the same thing, right? So here you should have gotten 64.8, and then you would have added, right? Elijah? Is that not what we just did here? Oh, yeah. Yeah. So you just didn't write down your steps. Yeah, you should really be writing down your steps before you put them in the calculator, though. That was kind of our agreement if you're going to use the calculator, was that you have to write the steps down. Can anybody tell me, could I do 124% times 270 and get the answer? What would 124% times 270 get you? I want you to try this on your calculator. Do you remember where the percent button is? Okay, so let's look at that. And then I want to think about this. 120% times 270. What do we get? It should have gotten me the exact amount. Oh, I did. I put it in the calculator wrong. Thank you. I'm on the struggle bus this morning. Times 270. So 124% times 270, and that gets me 334.80 without doing any adding. Can anybody tell me why that works? How does doing this, how is that the same thing as that? Because here I just multiplied and I got the right answer. I want you to think about that. What do you think, Faith? I did it backward, but I didn't do any adding. Or did I do adding? That's the question. Did I do any adding? So here, this is the 24%. This right here is 100%. Right? So 100% of 270 is 270, all of it. And then this is 24% of 270. So here I found the percent and then I added the numbers. What did I do on this one first? I added the percents. So this is 100% plus the 24%. So I did do my adding, right? So I did work backwards. But do you see how this is 100% and this is 24%? And so that I had to take them and I had to add them together. So this is another method that you could do. You could take 100% of the price plus 24% of the price, multiply that by 270, and you get $334.80. So I've seen questions on Milestones Prep about how these two things are the same, right? So how you could do something like that. Anybody have any questions about that? Okay. Do what? It would. So like if you wanted to find, if you had to pay 6% tax, instead of saying times 6% and then adding, what do you think you would multiply by? 106%. Because you'd be paying 100% of the price, and 6% of the price is 106%. So anytime that you need to find a total amount, not if it's a coupon, it doesn't work, because do we add with a coupon? No. But anything that's sales tax, a markup, a tip, anything like that, it would work. All right. Let's look at number 4. I don't think it's going to work with number 4. I mean, I guess it probably could. Let's look at it. Stella takes her dog to be groomed. The fee to groom the dog is $75 plus $6.75 tax. She also wants to leave a 20% tip. How much money will she pay the dog groomer? So it actually might be easier to solve it the way we just did. We would pay 100% plus 6.75% plus 20%. So I could add those up. I could say 100 plus 6.75 plus 20%. So how much would I need to multiply by? 75621. That would be our percent we're multiplying by. 126.75%. And so we would say 75 times 126.75%. Let's see what we get. You got your calculators? Do that. 75 times 126.75. And make sure you use this percent sign. $75 times 126.75%. And we got $95.06. And was that our answer? Yes. So that way might be a little easier, don't you think? Because what we were doing was we said, what most of us did, and what I did the first time, was I said 75 times 6.75%. And then I said 75 times 20. And then I added them together. So this was $5.06. And then this was $15. And then I added them together. 75 plus 15 plus $5.06. And you got $95.06. So either way you did it, it did the same thing. This was the tax, and this was the tip, and this is the total. So either way you want, any way you want to do it. Yes? So what I think that you did was I think that you found the tax, and then I think you said $75 plus this. Then you got a total, and then I think that you multiplied that by 20%. I think you found the total with the tax before you found the tip. But in real life, you don't pay a tip on the amount plus the tax. You just pay your tip on $75, and you just pay the tax on $75, and you do your adding at the end. Does that make sense? Don't find a percent and then add and then find another percent. That's not the way we do it. So a more efficient method might have been this right here. Add up the percents and then multiply. All right, questions? No. Okay, we are going to start our next unit today, our geometry unit. We're going to start with angles. Make sure you've got your journal. Make sure you've got your journal. And let's label the next 20 pages in our journal. So let's see where we stopped off at. So I think 85 was the last page that we added. Would you agree? So let's go ahead and number our pages to 105. So 86, 87, 88, 89, and let's go up to 105. Yes, please. Once you're done numbering, we are going to skip a few pages. So here was 85. We're going to skip 2 sets of pages. Skip this and skip 89 and go to about 91. Go to 91 and we're going to glue this angles up at the top. We're going to start our geometry unit with angles. Angles. So you've talked about angles before in the past. I know you have. You did in 6th grade. I think you did in 5th grade. So let's talk about the different kinds of angles before we learn some new ones. So let's talk about some things that we know about angles. So over here on page 90, draw an angle that looks like this. Right? You can fit a little corner of a piece of paper in that. Anybody know what kind of angle that is? James? That's a right angle. And what's important to know about a right angle? What's the measure right here in this right angle, James? There was a lot of Jameses in this room. What is it, James? 90 degrees. And so normally you're going to see this little square right here in a right angle. And it means that this is 90-degree angle. Okay? So then, draw a smaller angle. Draw this flat right here. Make sure your rays have arrows on the end. Anybody tell me what kind of angle that is? Emmy? Acute. It's a cute little angle. And what's important to know about an acute angle? Yeah? What does that mean? What's important to know about it? Somebody besides James. James, I know you were in my class last year. Come on, man. All right, anybody else? Less than 90 degrees. Okay. What other kind of angle do we need to draw now? An obtuse angle. So again, it has a flat bottom here. But we need to go this way. And that's an obtuse angle. And so if a right angle is 90 degrees and acute angle is less than 90 degrees, what is an obtuse angle? More than 90 degrees. And so this right here is more than 90 degrees, that measure. There's one more, and I don't know that you've learned this one yet. It's a straight line. So if our vertex was right here, it should be a little bit straighter than mine is. I've got too much in my journal, and all the foldables are making it bumpy. This is a straight angle. Anybody know the measure of a straight angle? No, not 360. But what is it? No, not 0. Matt, did you say it? 180 degrees. Let's talk about that. I like that. How? Let's talk about that. Let's see. I need a piece of paper. Let's have a quick lesson. Shh, ladies. Ladies. Okay, so here's a circle. What's the measure of a circle if you go all the way around? Anybody know? Skateboarding, what's it called when you go all the way around? A 360 degrees. Shh. There's a lot of chitter chatter that I find very distracting. Okay, so let's think about that. Let's just draw two lines like this. Okay, so we've already said if we just had this right here, if we just had this angle right here, what would the measure of that be? 90 degrees. And so what would this one be right here? 90. And this one right here would be 90. And this one right here would be 90. What is 90 times 4? That's 360 degrees. So if I said from here to here to here to here, that's 360 degrees. Does everybody see that? And so when we're talking about a straight line, we're just talking about these two angles put together from here to here. What's 90 times 2? Is 180 degrees. So we're talking about this section right here to form a straight line. It's a 90 degree and a 90 degree. Together they make 180 degrees. Does that help that make a little bit more sense? Yes? Okay, so we're not necessarily talking about going all the way around that makes 360. We're talking about these different angles right here that make 360 degrees inside of the circle. Okay, so these are the 4 kinds of angles you need to know. A right angle, acute, obtuse, and a straight. And this, the straight is 180 degrees from here to here because we've got two 90-degree angles, two imaginary 90-degree angles right there, a 90 and a 90, make 180 degrees. Does that make sense? Okay, so this is basically knowledge that we know. This is something that we're adding to it. And now we've got to learn a little bit more about some angles. And so we're going to learn about some angle relationships over here. This is how angles relate to one another. All right, let's start here with adjacent angles. Adjacent angles are two angles that are next to each other. This is the important part. Angles that are next to each other. And they share a common side. So an example is draw an obtuse angle like this. And from the vertex, just draw an angle straight up. So this could be angle 1, and this could be angle 2. And those are adjacent angles. Angle 1 and angle 2 are adjacent. They are right next door to each other. All right. The next thing that we need to talk about are vertical angles. So just make an X like this. So just make an X and then put arrows on the end. And so then how many angles do we have? Well, we have 1, 2, 3, 4 angles. Vertical angles are two angles across from each other on intersecting lines. Intersecting lines are lines that cross. Vertical angles are angles that are across from each other. What does the word congruent mean? Anybody know what the word congruent means? So when last year, maybe 5th grade, when you had two different squares, Sometimes they were congruent. They were the same shape and same size. Sometimes they were similar. Same shape, different size. So similar means same shape, different size. Congruent means same shape, same size. We need to write that over here. Same shape and same size. So if they are vertical angles, they are also congruent. So vertical angles are across from each other. So we have two sets of vertical angles here. Angle 2 and angle 4, they are vertical. And what's the other set of vertical angles? 1 and 3. So let's make a note over here. Angle 1 and angle 3 are vertical and congruent. Angle 2 and angle 4 are vertical and congruent. I hadn't glued mine down yet. There we go. We're going to talk about the other three things on this page on Wednesday. The only thing that we're going to focus on today are adjacent and vertical angles. So we are also going to work on this green paper. So go ahead and cut it out on the dotted line, the outside dotted line. And we'll look at that in just a minute. Make sure you finish these notes. All right, so we've cut the outside off, and then we've cut these top parts apart, and then we're going to focus on these last two, adjacent and vertical angles. Look right here under the flat for adjacent angles. Let's take a look. What do we remember about adjacent angles? Well, adjacent angles are next to each other. So, take a look here. This says angle ACB. So start at the A, angle ACB. That's this angle right here. ACB, and angle ACD. ACD, that's this angle right here. They are next to each other, so that makes them adjacent. You have to be able to identify angles, and then you have to be able to identify the relationship to the other angles. Those two are adjacent. So two, let's fill in the notes down here. Two angles that are side by side. They have a common vertex. Vertex is the point in the middle. And they have a common side, right? They share this vertex right here. And they share this common side. Ray AC is their common side. So they share a vertex and a side. They may or may not be congruent. And what does congruent mean? Same shape and same size. Are these two angles congruent to each other? No. One's 75 degrees and the other one is 105 degrees. So they are not congruent, but they don't have to be next door to each other. All right? Anybody need more time on this one? All right, let's look at vertical angles. Vertical angles. So close that flap and let's look at this one. Angle LMN. Let's find angle LMN. So start at the L. LMN. That's this top. And angle OMP. Start at the O. OMP. These right here. They are vertical. They are across from each other. Those two are vertical from each other, which makes these two vertical from each other. Use a different color. So LMO over here. And NMP, these two are vertical from each other. They are the same size. These two are 140 degrees, so they are vertical, and these two are vertical from each other. They are the same size, okay? So they are vertical. So they are two angles that are formed by intersecting lines. That means lines that cross. They are always congruent. What does congruent mean? Same shape and same size. They have the same angle measurement. So another example down here. These angles are vertical. Angles X and this one. These are X and 115. They're vertical. So if this one's 115 degrees, what's X? What's the measure of X? 115 degrees. Angle Y and this one are vertical. So if this one is 65 degrees, what's the measure of angle Y? 65 degrees. And what we learned about a straight line, what should these two be if we add them up? 65 and 115. Do you see how they make a straight line? If you add that up, those should be 180. So that's gonna be the next place we move. All right, questions on adjacent or vertical angles? Anything? Okay, let's look at the skills practice today and some of those questions on the skills practice. We've got about 5 minutes left, so let's get started on the skills practice. And then we will finish up the skills practice tomorrow. So you do not have to do it for homework. But let's look at some of these questions. All right. Skills practice. Classify angles. Name each angle in 4 ways, and then classify it as acute, right, obtuse, or straight. So, naming this angle in 4 ways, we could call it angle A, B, C. It could also be called angle C, B, A. Do you notice how the vertex is always the middle? You can name it A, B, C, or C, B, A, but the vertex always has to be the middle. You could also call it angle B. You could name it just after the vertex. There's one more name. We could also call this one angle 1 because it has a 1 right here at the vertex. Those are the 4 different ways you can name it. So, ABC, CBA, angle B, or angle 1. And if we were going to classify it, what type of angle would that be? Shay? It's obtuse. Okay, so this is what you're going to do on 1 through 6. Name it 4 ways and classify it. Down here, 7 through 12. Refer to the diagram at the right. Identify each angle pair as adjacent, vertical, or neither. And remember, adjacent means next door neighbors. Vertical means across from each other. So, let's look at angles 7 and angle 12. Angle 7 and angle 12, they're next to each other. They share this vertex and this common side. That makes them adjacent. So when you work on this tomorrow, do you think you might need your notes from your journal? Yes. All right. Down here, refer to the figure at the right to determine the measure of each given angle. So let's take a look at 13. Angle SYX. SYX. We're talking about this one right here. What is the measure? So if I look straight across at its vertical angle, what is the angle straight across? 76 degrees. So what does that make this one? 76 degrees. Okay, so you will be able to use a neighbor next to it or a vertical angle across from it to figure out the measure of the angles. All right, so we're going to work on this tomorrow, front and back. So go ahead and clean up for today. Make sure you don't lose this paper.